Okay, let's do a little bit of house cleaning. Can we assign the first half, that's string substring string zeroed I, can we assign that to a variable?
No, because string substring needs to have three different things in it.
Yeah. So can you highlight the entire expression? String substring string zero I. That's including the closing parentheses. That's Control X for cut. And then let's create a new line after line 3. Uh, Paste. Okay, and let's at the start of line 4, let's delete the opening parentheses there. We don't need that. Let's call this variable first half. Or maybe before I. So before hyphen I.
Like uh, like hyphen I equals to string substring,
Yep.
or
Yep, exactly.
how does hyphen look like? Sorry.
Oh, can we call it before I? Like before hyphen I?
What do you mean?
Like BEFORE?
Before, yeah, before I.
Yeah. But one word. So before dash I. Dash. Nice. Okay. So the reason why I'm doing this is just to like clean things up, make things a bit neater. Okay, let's create a new line after line 4. Let's call it after I equals, can we, on line 6, that's the string substring expression. Can we take that? But without the string append. So just string substring. Right, and you can delete the string substring on line 6. Yeah, honestly, line 6 can go, yeah. Okay, so this is where we're at from yesterday. We want to get all the stuff after the I, right? So for
Yeah.
example, in line 13, we're trying to get the D, which is after position 0. And we're trying
Yes.
to get, line 14, we're trying to get the D again, which is at position 3. So we know that the start of the position is I, so you've got that part right. But what's the end position? What's the end index?
That's what I'm failing to grasp, because
Okay.
okay, the first str is a string.
Hmm.
I is the number,
Yep.
and the last one is the length.
The length. Okay. The length of the string? How do we get the
Yeah.
length of the string? Is there a thing we could consult that might tell us where we could get the length of the string? Yeah. String length. Could we use string length somehow?
So we need to have. So we need to use it before it to determine the length of the string, and then put it here. Or
Yeah, where the cursor is at, we can just put it in.
oh, okay.
Yeah. Very nice. Okay, so we got our two pieces. So we have before I and after I, and we need to join them together with an underscore, right? How do we do that?
And we do before I. Can we do before I plus after I equals, or is it the same thing or
So
not?
you
Before
can
I
do that.
understand.
You can use plus for append. Just don't forget the underscore, right?
Yeah. Wait, I'm sorry. For append.
Yeah, yeah, you can use plus to append two strings.
Yeah.
Uh, we don't need equal sign, right? It's just an expression. But the underscore needs to go somewhere. Where does the underscore go? So in the problem, where does it say the underscore should go?
The ith position.
Okay, and inside line 6, where is the I position?
Like both of these are I position.
Well, that one's before I is before I, right? And after I is after I. So that means where is I? Okay, let's try running this. It seems to be putting the underscore at the end.
What if I change the
Okay, beautiful. Yeah,
I kind of they seem easy once you kind of understand.
yeah.
Like yesterday I struggled with this. Spent an entire hour doing this. It was a bit embarrassing.
Oh, it's all good. It's all good. No, it means you're learning. Now that you've crossed this hurdle, you have become stronger as a programmer. And yeah, I mean, becoming stronger as a programmer, you gotta go through a lot of pain and suffering. And I think that's true
Yeah.
with everything in life. All right.
Yes.
There is one thing you could also do instead of line 6 before I plus underscore plus after I. We could use string join, right? Which is a function you've created yesterday.
Oh,
Yeah, you see, if you scroll on the string join, right? What does it do? It takes two strings and puts an underscore between them,
yes.
right? So we could use string join there. You want to give that a try?
So instead of this,
Yeah, we call string join. And what are the two things we're joining?
two strings,
The two strings, yeah. And what string specifically in our case?
and an underscore.
Ah, but string join does that for you, right? String join adds the underscore for you, so you don't have to write it on your own. So everything you need is up there.
So before I and
Yeah.
after I.
Yeah. Exactly, right? Those are the two strings you're trying to join together with the underscore in between them. And that's exactly what string join does. There's a bit of a typo after I, not after Y. Cool. Yeah, that's if you run this, there's gonna be a slight problem. Oh, wait, what? It worked? Oh, it worked. Okay, yeah, never mind. Sorry, no problem at all. This was perfect. Nice. Okay. Uh, I have one final challenge for you before we move on. Let me find it. This is the big boss. Uh, I've just pasted it in chat.
Consumes a string plus a
Uh,
number I. Is that what it says? Consumes a
oh no, no. Sorry,
plus a number I.
sorry. The plus means n, like A and D. As in, it takes two things, a string and a number I. The A is an
Okay, then.
article.
Sorry.
Yeah, oh, good.
String and number I.
Yes, yes.
So a string, and it deletes the ith position.
Mm-hmm. Oh, so I like how you started with empty string. It's not possible with an empty string, right?
Yeah.
Okay, what's the next simplest case after an empty string? Oh, it's fine. You can keep
One.
this. Yeah, okay, let's finish this example and let's move on to one character after this. Cool.
So if it's a 0, then the string should be empty.
Yeah, right? We're deleting the first character, which is the only character, so it's empty now. Can we delete something that's not the last character? Can we delete something in the middle? Just to mix up our tests a bit. Okay, while we're on this topic, notice how whether or not the third or fourth character gets deleted, the result's the same for tree.
What do you mean the result is the same?
So let's say there's a bug in our code and we delete the last E instead. We get the
Yeah.
same result, right? And the test will pass.
Yes.
Can we change the 2 to a 1? So we delete the R instead. You see why we did that? Does it make sense?
I'm not sure I understand what is the difference if I.
So here, notice how we're missing the R, right?
Yeah.
If we miss the R, that means we must have deleted the 1th position.
Yes.
But let's say we wanted to delete the E, but there are two E's. What happens if we delete the wrong E? Will we have known?
Yeah, the will still pass the test because there's
Exactly.
two letters, two. So yeah, yeah.
Yeah, so this is the art of like making good test cases. So yeah, that's something to consider there. All right, the test looks pretty good. Shall we move on to the body?
Well, we need to use the substring here as well because it also consumes a string and a number.
Hmm. Yeah.
So we have a string join here that adds them
Well,
together.
because
And
that string join
hello?
also adds an underscore, right?
Yeah, yeah, but we don't need that here in our task. We need to delete the
Yeah.
position, so we need something else.
Yeah.
Okay, I think maybe we can use this.
String replace.
Yeah, because you
So,
can remove stuff.
okay, but the string replace, what does it take in?
A string.
Well, there are three strings, right?
Yeah, so we have yeah, it doesn't work.
Yeah, it doesn't take in an index. There's no notion of positioning. Okay, I'll give you a hint. All can be achieved with string substring. So you know it's from 0 to I, right? We keep 0 to I, but how about the rest of the string? How about the stuff after I? We
Stuff.
The stuff after I, we want to keep most of it, right?
Yeah, yes.
So should we
We're
have a
just
second?
removing we're just removing one.
Oh, okay.
So
Is there a
Like
way to get?
if it's three, we're removing one
Yeah.
and we keep the double E.
Okay, so we need a second string substring. But what should the start and end index be?
This,
Okay, can you show me?
like all of this.
But we need a second one of that, right?
Do we need a do we need a before and after then here as well?
Yeah, because like, for example, for tree, we got the T, but what happened to the EE, right? We need a before and after, right? Do you agree? Do we need a string substring here?
I think so.
All right, so let's write it down. String substring. Okay. And what string are we substringing?
Like this.
Okay, which is the parameter str, right?
Yes.
Right, that's what we are trying to cut out of. Okay, what's the first position? What's the start index of our substring?
T.
T.
So it's a
So,
zero.
well, this is the past the point of deletion, right? So in the case of tree, what's the start index?
Do I have zero?
But for the latter half, like after the thing we're deleting. So in line 11, tree, what's the start index of uh the E? What's the index of the first E?
Two.
2. How did we get 2? How do you know the 2 was the start index of the second half of the string?
I got it here.
How did you get it there?
No, we got this from this.
Mm, does it 0 to I? When I is 1, what does that get you?
When the zero is one, when the I is one,
When the I is 1, yeah.
you get this.
Do you? When I is 1? When I is 1, sorry, when I say I is 1, I'm referring to line 4. On line 4, when we do string substring string of 0 to 1, what does that get us? The whole thing?
No, we don't get the whole thing.
Okay, what do we get from line 4?
We get everything before it is cut off.
The T, we get the T,
Yeah,
right?
you get the T, yeah.
We get one letter. So what happens to the rest of the letters? How do we get them back? Here we need EE, right?
R gets removed and we are left with E.
So how do we get EE?
Do we need the string length here or?
Okay, and how do we use string length? So how does string length help us here?
Well, it determines the length.
Okay. And what can we do with the length?
So in here,
Mhm.
I think something related to the R should be like
Yeah.
maybe because it's like the starting index, but it gets removed.
Okay. So it's related to R. And it related in what sense?
Well, it's this because it's no, like it's we're doing trying to figure out the after I.
Uh-huh.
So the next one should be the starting index. R gets removed. R is gone. So that
Yeah.
leaves us with an E.
How do we get one past R?
And a plus one.
Okay, can you show me?
No, I'm just guessing. I don't know. I
No,
mean,
no, 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 yeah. Yeah, it's okay. Can you write it down? Just so we can get a picture of what it looks like.
something plus one. I don't know what.
Okay, and you say in relation to I, right? So what should be the something?
I plus
I
one.
plus one. Okay, that seems pretty promising, right? I mean, that makes sense.
And the remaining should be the length of the string.
Okay, yeah, can we try that? Cool. Okay, so we got before I and after I. What do we do? We done?
No, we're not done.
Okay, we got two pieces, but we need one thing.
We need to join them.
Okay, how do we glue them together? With string join? Do we need an underscore?
But we do not. Can we just if we write them down in parentheses as strings, can we do that like this?
Um, no, those are literally the strings before I after I. But you want to glue the contents of the string, right? We've done this before. How do we glue the contents of a string? Remember arithmetic with strings?
Is there a plus?
Yeah, we can just use plus, right? Which is what we did just now.
So
Oh,
is it
we deleted it. We could also use string append. Either works. Okay, let's run it. Let's see what happens. I think that's a minor error. Yeah. Ta-da! Nice. Okay. So yeah, the key idea here is I plus one. Because you knew it's like, oh, we have to do something with I, but we can't just start at I, because that's the thing we're trying to delete. So we do I plus one. Make sense?
yes?
Awesome. Okay. All right. Congratulations. You have done the first. These exercises I usually give to people so that they get familiarized with the mechanics of the language. So you are pretty comfortable with the language now. I can see that. And so we're gonna move on. I wouldn't say we're really programming yet. We are. But there is one key idea that I now want to talk about, and that's the idea of the translation between information and data. Remember that?
Yes.
Okay. So two things moving forward. The first thing is I need you to install Visual Studio Code at your own time. Are you familiar with that software?
I've heard of it, but I've
Okay.
never used it, but I mean, I'll install it.
Okay, I'll email you the instructions. It's fairly straightforward, but that I do have a guide for this. So in the future, with that software, it allows us, like you and I, to type in the same place and in real time. It's like Google Docs, but with programming.
Okay.
So that's number one. But for now, I'm going to just use a whiteboard that you and I can share, and I'm going to introduce us to our next thing. Uh, so I'm going to start a session.
Should I stop
Uh,
streaming then?
yeah, I'll share my screen. And then I'm going to... All right, so there's a lot of stuff here already that I've done with other students. So we need to find a space for ourselves. Let's go to...
So
Okay.
do I look at this whiteboard or at the translation? At the
Oh,
stream?
you got to find me. Can you click on my name at the top? I believe I'm Upbeat Kraus. Can you click on the U? You'll teleport to me.
Yeah.
There we go. Okay, so here's our own space. So you sort of saw what I did with the other students, and we're going to do something similar. It all begins with this idea, information and data. And zoom in until that looks normal size, that text. You see the text?
Yeah, it looks fine.
Okay. Information and data. This is the foundations for everything that we'll be doing moving forward. So far, we have done nothing about this idea when we were doing the exercises because I just wanted to get you familiar with how to use functions and calling functions and whatnot. Now that you are familiar with it, we can now begin. We can truly begin. Begins with this idea of information and data. Our job as programmers is to turn information to data, operate on the data, and turn data back into information. All right. So what is the nature of data? So I want you to picture a box. In fact, you don't have to picture it because I'm going to draw it. This box is everything. Everything all is our universe of data in this programming language. Okay? So what are some examples of data that you saw?
Like books,
Data, like in our programming language. When you wrote data, what were you writing?
like functions and stuff.
Functions operate on data, but they're not themselves data.
Like ones and zeros.
Ones and zeros, yeah. So one, zero. Okay, what other examples of data have we seen?
Strings.
Strings. Okay, can you write some strings? I'll write one for you. So hello world. Can you write other strings in here?
Can I write here? All
Oh,
right.
yeah. At the top, you can see there are some like options. Can you click the A that says text? If you press T on the keyboard, that will also work.
I pressed Shift 2 and I zoomed out.
Oh, you can zoom back in by control and then scrolling in. Scrolling up, I mean, sorry.
Is that you writing tree? Yeah.
Yeah, that's me. I'm Upbeat Grouse. You're the wise aardvark. Duck. Yeah. So we saw a bunch of strings, right? What other kinds of data have we saw? Have you seen?
There's Boolean data.
Yeah,
True and
booleans,
false.
right? True, false. Can you write true and false? Oh, it's lowercase t. It's case sensitive, yeah. And then one more false. Excellent. Okay. Very good. So this is our world of data. We don't actually need this to be that big. So we saw in our world we saw zeros, ones, and there are more numbers as well. There's two, there's two, and so on and so forth. We saw booleans, we saw true and false, we saw strings. We also saw images, but I'm not gonna draw images in here. Anyway, remember we gave them names, right? Like for example, numbers, we said that they were a data type, right? Booleans and strings. Remember that?
Yes.
So when I say like number, you know what I'm talking about, right? Like 0, 1, 2, 3. We name we gave a classification of data, we call those data types. Right? We got the real numbers. Remember that? We have the booleans. You saw strings, right?
Yes.
So far, so good.
Yep.
So we saw three
So
data
I'm
types.
sorry.
Yeah.
So strings, booleans, and the first one is real numbers.
Yes, R for real numbers, yeah.
Okay.
Oh,
Okay.
yeah, I guess I should talk about it now. So yeah, we've only worked exclusively with integers. I guess you might have saw decimals when you did like distance. But yeah, like we can have decimals, we can have negative numbers, we can have, oh yeah, this language you can also write exact fractions. You can always do that. But yeah, lots of numbers. Boolean is unique in the sense that it's only two values.
Mhm.
Right. Yeah, okay, whatever. Okay. Anyway, so yeah, we have the universe of data. I'm gonna move this a little bit to the right. But data is just data, okay? But they're meant to represent information. Remember that? So here's a quick case study. Let's say, and I'm just gonna write on this board. Um, let's say here's the situation. We are a thermostat software company. Okay. We do things with temperature. And let's say, um, I have, we're dealing with temperature as information and we want to encode that as data. Okay.
Yes.
Let's say that's the situation. The very, very, very first thing I want to do is I want to write the representation of information. So, based on what we know so far, what's a good way of representing temperature?
It's like Celsius and Fahrenheit. So is it degrees?
Well, numbers, right?
Yeah.
So
Yeah.
I can write we represent. No, actually, I'm glad you said all that. We represent temperature as number as a number. Okay.
Yes.
But you also mentioned Celsius, degrees, Fahrenheit. You're talking about units of measurements, right?
Yeah.
So the thing about numbers is that when you're dealing with measurements, you want to include a unit of measurement. So we add an additional statement. Uh, this temperature is in, let's say, let's start small. Let's start with Celsius. Okay, it's in degrees Celsius. Make sense?
Yes.
Okay, so there's two things going on here. Here's the first thing. Let me do this. We write a representation. The representation is for the computer. Computer, I'm treating this thing as a number. Don't worry what this is. It's a number. Okay? Right? You see that?
Yeah.
The second thing, we call this interpretation. Okay, human being, this is what this temperature means. It's measuring temperature in degrees Celsius. Make sense?
Yes.
So one's for the human, one's for the computer. I kind of want to talk about the representation. We represent temperature as a number. There are two conventions that we want to do. First, we represent, it's kind of mouthful. We could also say a temperature is a number. You see that?
Yes.
Okay. Second thing, the idea of temperature, we're going to keep referring to this idea throughout our program. We're going to say, oh, this temperature is this temperature is that. And I kind of want to capitalize the T, temperature. In fact, I'm going to even color it orange. Can I do that? Oh, I don't think I can color just a specific thing. Never mind. Can I? Yeah, I don't think I have a choice. Okay, anyway, yeah, so a temperature and I'm going to capitalize the number as well, number n. Okay? You'll see why we capitalize the T in temperature in a moment, but just know that we are treating temperature as if it's a data type. But it's not a data type because it's not, if you look at a universe of data, the computer has no understanding of temperature, right? This is like an artificial data type, right? Does it make
Yes.
sense? We call this a data definition. A data definition has a few parts. The first part, it has a representation. How does the computer understand it? It also has an interpretation, how a human understands it. A data definition
Sorry,
bridges, yeah,
interpretation is for humans and representation is for the computer.
yes, exactly.
Okay.
So yeah, what we have here is a data definition. Uh, yeah. So a temperature is the name of our data definition. We give names to data definitions. So that we can refer to them throughout our program. Okay? All right. Um, so when we say a temperature is a number, if we go back to the universe of data, what we're effectively saying is that our real number circle is a temperature. They are one and the same. You see that?
Yeah.
Okay. I'm actually going to move this to the bottom. And I'm going to downsize this.
So we give names to data definitions so that we can refer to them throughout our program. So that's like what we did with functions. Is that it?
Yeah, yeah. So the reason why we gave names to functions is so that we can call them, right?
Yeah.
Yeah, same idea. So a data definition is also a circle in our universe of data. It needs to be a well-defined circle. When we draw this smaller circle, we can definitely say what's in the circle and what's not in the circle.
I'm sorry, but what do you mean a circle? A
Um,
circle in our universe of data, what does
like
that mean?
the thing surrounding the R, like the box surrounding the R.
Okay.
Okay,
So,
it's a very rounded square, a rounded rectangle, but pretend that's a circle.
Yeah, yeah.
Um, if
So
you're
all
familiar,
data
yeah,
within that square.
yeah. So when we say real numbers, booleans, and strings, we are defining a boundary between what's a real number and what's not a real number. What's a boolean and what's not a boolean, right? There's no ambiguity, right? Does that make sense?
Yes.
So when you make a data definition, you need to confidently say what is part of what belongs to that data definition and what doesn't belong. So is the word hello world a temperature?
No,
Why not?
because it's not in our circle.
It's not in a circle. Okay, how about the number two? Is that a temperature?
Yes,
Okay,
because
why is it a temperature?
it's our data.
Okay, it's a number, and
It's
we say temperatures are numbers, right? So that's our circle.
yeah.
So in fact, that's what I'm going to do. I'm going to now create examples of our data definition. I'm going to say two. But here's the thing. I'm going to refer to this example throughout our program, so we need to give it a name. So I might say like temperature is two. Temperature something is two. But temperature something is a very vague name, right? So maybe let's make it more specific. The temperature two is two. Temperature is kind of long. So maybe T2. And typically when we're dealing with like uppercase letters, we use an underscore instead of a hyphen as a convention. All right. So the next step is making examples. See that?
Yeah.
I'm actually gonna change. I don't like the temperature. I feel like temperature. We could use any name. I could call this an aardvark. We could call this a grouse. But we want to pick a name that's very suitable to what we're dealing with. We're dealing with temperature, but more specifically, we're dealing with Celsius. So I kind of want to name this Celsius. What do you think? Celsius is
Well, it
good?
isn't. Yeah.
Okay, so I'm gonna rename our T to a C. So all instances of temperature is now Celsius. And so C2 is 2. What are some other examples of Celsius?
But do we need to give it a different name like C3, C4, C5?
Yeah. So okay, so you say C3, so that's for 3. But we could create an infinite number of examples, but let's pick the most
Yeah.
interesting ones. What are some interesting examples of Celsius?
I don't know, 60.
Okay, why is
Like a
60 an
big
interest?
like a big number maybe,
Could be.
like
Okay,
high
what's a big
temperature.
number?
I don't know, 100.
100? Okay, could you write that for us? C underscore 100 equals 100? So you should be able to click on the text box that contains our examples. You see where I'm at? Just click on that. And then you should be able to edit the text in it.
But may I ask, why do we need to have an underscore after
We don't
C?
have to. I personally like it because it looks better. Or like, let's remove it, right? It looks like this. I don't know. I don't know why I don't like it. But if you're fine with it, we can do this. Yeah, the underscore is optional. Like the name is completely up to you.
Okay.
I don't want to name it C4. I kind of want to name it C100. You know why?
Are you naming it for a specific temperature?
Yeah. And also because if I name it like C something, and I look at a name like, and I use this example later, like later in my code base, I do see something. I'm not gonna know what C something is. I have to scroll up, right? But if
Hmm.
we name it C100, just from the name, you know exactly what it is, right? Make sense?
Yes.
Okay. All right, we're out of time. Let's pick this back up next time. I'm going to send you the instructions for how to install and set up Visual Studio Code. And the next time we do this, we'll be doing this in an editor that we
No
can
need
both
to
edit.
install it for the next meeting then.
Yeah, I'll send you the instructions. If you have any trouble, no worries. We can do it together in
Can
our next
I
session.
can I access this in my free time? Like, do I need
Uh,
to?
you know
Can
what?
I bookmark it?
Sure, yeah, sure. Just don't mess around with other people's stuff.
Oh no, won't do, won't
Yeah,
do.
because I do all my work in here. But yeah, sure, sure. I'll keep it up for
No,
you.
no, no.
Okay. All
Okay,
right.
okay then.
Let's pause here. All right.
Thank
Good
you.
work today. I know you've been doing like some very strong mental training these past few days. Yeah, I can tell with 100% confidence that your brain has increased in gray matter.
Uh-huh.
All right. I'll catch you
Thank
next
you.
time, Victor.
Yeah, I'll
Bye-bye.
see you next time. Bye.